Hello and welcome to the ninth episode of my series of electronic tutorials. In this episode we're going to be going over the time constant, and I'll be going over what it is, how to calculate it, and how it can really help you in the world of electronics. Alright, so let's get started. So what is the time constant? So the time constant is a way to determine the time it takes for a capacitor to charge. So as we mentioned in the previous video on capacitors, they soak up the voltage and charge themselves like a battery. Now, while the calculations are usually simple in electronics, well, based off what I've told you so far, this one is kind of tricky. So the fact of the matter is that when you calculate the time for capacitors, you have to realize that a capacitor doesn't charge at a constant rate. So that means it'll charge rapidly in the first 5 or so seconds and then decrease over time. So it's not a constant charge. Alright, so now that you know what a time constant is and you know what it's used for, let's figure out how to measure it. Alright, so this is the formula, and as you can see it says Tc equals R times C. I'll be going over each individual variable. So Tc on the left is obviously time constant as labeled there, and then R represents the resistor of R ohms, so the amount of ohms the resistor is, and then the C represents the capacitor of C farads. So the unit for the C would be farads, and the unit for resistors or R would be ohms. So now that you know what the variables stand for and how to calculate it, let's do an example so that it's easier to understand and remember. So in this example, you're going to be given a 1K resistor and a 1000 microfarad capacitor. So in order to do the calculations, like I said, you had to have the correct units. For R, it was ohms, and for C, it was farads. So we have to convert these. So the 1K resistor would be 1000 ohms, and then the 1000 microfarad capacitor would be 0.00 farads. So now we plug it into the equation that we have. So the time constant equals 1000 times 0.001. So we just substituted the R and the C with numbers, and you get 1. Now the important thing to understand with time constant is, like I mentioned, it's kind of tricky as it doesn't charge at a constant rate. So this 1 second represents the time it takes to charge 63% of the capacitor. So this isn't the time it takes to charge the full capacitor. So now that you know that, we can discuss what happens next. So it only charges 63%, so how do we charge the full 100%? So let's go over that right now. So continuing off the concept I mentioned before about the 63% charge, now we have to think of what happens afterwards. So after the first second that you charge the capacitor, the second actually charges 63% of the remaining battery. So instead of charging the full battery in 2 seconds, it only charges 63% of what's remaining. And this follows for the third second and the fourth second, however many times it takes to charge the full capacitor. Alright guys, so that's it for this video. As usual, I hope you understood everything about time constant. So it's really important that you understand this because it relates so much to the capacitor unit we went over. Just to give you a quick overview, the time constant is what we use to measure how long it takes for the capacitor to fully charge. As the capacitor doesn't let current through, it charges the voltage like a battery. So if you have any questions, leave it in the comments below, or you can email me through the website. And I hope you understood everything. Alright, thanks.